Let's take a look at a real-life example of exponential decay. For her 5th birthday, Nadia's grandmother gave her a full bag of candy. Nadia counted her candy and found out that there were 160 pieces in the bag. Nadia loves candy, so she ate half the candy on the first day. Her mother told her that if she eats it at that rate, it will be gone the next day. Nadia devised a clever plan. She will always eat half the candy that is left in the bag each day. She thinks that she will get candy every day and her candy will never run out. How much candy does Nadia have at the end of the week? Would the candy really last forever? Let's remind ourselves of the function for exponential growth and exponential decay. A is our starting point. In this case, that would be 160 pieces of candy. B is our change. Our change is that we're cutting the candy in half every time. We'll use x to be the number of days. So let's write a function. Y equals 160, our starting point, times 1/2 to the power of x. Remember that if b is greater than 1, the exponential function increases. But if b is less than 1, but always has to be greater than 0, then it is a decrease. 1/2 is greater than 0, but less than 1. So in this case, we will be decreasing, which we expect to happen as Nadia eats her candy. Let's take a look at the table of values for Nadia's candy equation. Here is the table of values for Nadia's candy. As you can see, when she started at day 0, she had 160 pieces of candy. After the first day, she had eaten half and was left with 80. Using her clever plan, Nadia wondered, how much candy would she have at the end of the week? After 7 days, she would have 1.25 pieces of candy. So even after a week, Nadia will still have candy. Let's now take a look at the graph and see the exponential decay of Nadia's candy. As you can see, the number starts high at 160 and decreases more and more and more with each day. But the graph will actually continue, not quite touching the line. So, will Nadia's candy last forever? We see that by the end of the week, she has 1.25 candies left. So there doesn't seem to be much hope for that. But if you look at the graph, you will see that the graph never really gets to 0. Theoretically, there will always be some candy left, but she will be eating very tiny fractions of candy every day after the first week. This is a fundamental feature of an exponential decay function. Its value gets smaller and smaller and approaches 0, but it never quite gets there. In mathematics, we say that function asymptotes to the value 0. That means that it approaches the value closer and closer without ever actually getting there.